Hello, everyone, and welcome to McCall's Science Enrichment. This experiment today is entitled Rainbow Paper, and here are the materials that we will need for this particular experiment. The most important thing today you'll need is a low container to hold your materials. This will be where all of our ingredients will be gathered together in this particular pan. I would not recommend using anything that you normally eat food from. So if you have Tupperware or glassware or ceramicware that you use to bake or cook or whatever, I wouldn't recommend it for this particular experiment because some of the materials today are going to be toxic. They're not going to be suitable for containers that use food. So today I'm using an aluminum tray. I think that'll be okay. This is disposable. When this particular experiment is done, I'm just going to recycle this and then that'll be it. So in our aluminum tray, your second ingredient today is going to be black construction paper. Now you can use other colors, but I would recommend using dark colors. The darker, the better. So today we're using black. Now this construction paper should be clean. It should be free from dust. It should be free from fingerprints. And you want to make sure that all of your black construction paper is to the size of your pan. You want all that paper to be able to go inside that pan and fit inside, and that's wonderful. So the next ingredient today, of course, is our good friend. Of course, we have water. You'll need some water to put into that pan. You will need something today to be able to lift the pieces of paper from the tray. And I'm going to use this little bamboo skewer today to make sure that I don't poke myself, boink, 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 nothing like that. Safety first at all times. You will need some clear fingernail polish. It doesn't matter what brand, it doesn't matter how expensive. I'm told that the cheaper brands are better for this particular experiment. But one thing I want to say about clear fingernail polish is that this stuff is toxic. You might want to wear gloves for this particular experiment. And you don't want to put any of this anywhere near your mouth or your face because this stuff is really hazardous. It's made of combustible materials. That means that this stuff has a very harsh smell. It's full of chemistry that is very, very, very dangerous. Now, people put this on their nails all the time. I don't, but I know many people that do, and that's a fine thing. But when we start using this fingernail polish today, it's going to have a very, very harsh smell. You're going to smell the dangerous chemicals in fingernail polish. Now, if you don't believe me, here is the box that came with this particular brand of fingernail polish. Now, that is in Spanish. That would be bad. Ah, there it is. So among the many ingredients here, we have alcohol, we have ethyl acetate, we have butyl acetate, we have heptane. Oh my gosh, those ingredients here are really toxic. They are combustible. If you get a little bit of this stuff on your skin, which you could do with today's experiment, and you go anywhere near an open flame, you can burn. This stuff burns. It is combustible. It will catch on fire. So whatever you're using today, as long as you can wash up and get all the stuff off your skin, or wear safety gloves and get rid of those gloves, and throw away all your materials because this stuff is very, very flammable. It's very, very combustible. Be very, very careful using this stuff today and make sure that everything is cleaned up. Now that's it for materials. Let's go on to our procedures. Hang on. Alrighty, our step-by-step instructions or procedures for this experiment go just like this. The first thing you want to do is put your tray on a level surface. You don't want this tray to be tilted in any way because that'll just make it much, much harder to do this experiment. The first thing we're going to do is fill our tray about 2/3 with water. If your table is not level, this will be when you see that happen. That's pretty good. Alrighty, so I'm now going to take one piece of black paper. This is my largest one, and simply put it in. Now you want to make sure that that paper is below the surface of the water. And being construction paper, this paper should begin to absorb that water, and there we go. Just make sure that it's below the surface and you'll be fine. Okay, so our nail polish now is going to be placed into the water, and you only want about a drop. Now this stuff smells. I mean, it really smells. The reason why nail polish is put together the way it is because this stuff dries into a hard surface on somebody's fingernails, and to help it dry, solvents are added to this stuff, And those solvents, of course, are combustible and dangerous, and this is really going to smell. Now, they say all you really want to do is put about a drop of this into the water. You want this nail polish to be as thin a layer as possible on this water. Now, I could take the cap off and pour it in, but I think that's going to be too much. So I've decided that I'm going to remove my cap here. There we go. And what I'm going to do here, I could take this little brush and simply touch it in the water. But then that's going to contaminate this brush, and there's going to be water in this brush, and when I put the brush back in the bottle, that's going to contaminate the bottle. So I don't think I want to do that. I think instead what I'm going to do is I've cut a little piece of plain plastic straw. And I'm just going to take that plastic straw, dip it just a little bit into there, and then I'm going to touch that straw, just like that, to the water. Now, this camera should be able to see that once I touch that straw with the fingernail polish to the water, now I have sort of a round-shaped rainbow. You should be able to see it, okay? Now, what I want to do is I want to grab a hold of one corner of the paper. And I want to lift that paper out of the water. And as I lift, that rainbow is going to attach itself to the paper. You should be able to see that rainbow there. Now, I'm going to do this process another 3 or 4 times, and then we'll come back and we'll talk about the science on what you just saw. Hang on. Wow, I have to say that the smell of this fingernail polish is so strong. I made 2 prints and I allowed them to dry a little bit. Here's the first one that you saw in the video. Very pretty, isn't it? All the colors are fixed to the paper. They're attached to the paper now. And as this fully dries, this will make something really beautiful, maybe a card or a gift or a little note to somebody. That's good. The second one that I did, I sort of did several mini circles and then picked the paper up, and actually pretty neat. I mean, all different, no two the same, lots of colors, lots of variation, and there it is. Now, why are we seeing what we're seeing here? So let's talk about our 2 liquids here. We have the fingernail polish, which is a liquid, and this dries with the smell and then becomes a solid, and then we have our water. Well, we need to talk about the word density here, because things that are more dense sink. They fall to the bottom of a container. Things that are less dense float up. So between these 2 liquids, the fingernail polish and the water, which one is denser? Well, the water is denser. Fingernail polish is lighter than the water. So when we put fingernail polish in this water, that fingernail polish floats up on top. Now, the thing is, this water is not flat on the surface. No, if I move this water around just a little bit, you can see waves going across that water. And that means that the surface of the water is kind of going like this. Well, if the fingernail polish is floating on that water and the water is going like this, so is the fingernail polish. That layer of fingernail polish floating on top is very thin, and it also has peaks and valleys. It goes up and down. And that is exactly the reason why we see colors in this paper. This fingernail polish, that the layer that's attached itself to the paper, is not a flat surface. No, this fingernail polish is just the way that it was in the water. We have areas of this fingernail polish that are a little higher, and we have areas that are a little bit lower because of the waves of the water. And because the thickness of this fingernail polish changes, the color changes. As the thickness of the fingernail polish on the paper changes, the color will change as well, okay? So this is reflected light now that you're seeing, and that reflected light is reflecting off the surface of this fingernail polish. The color changes as the thickness changes. Now, I'm not sure if, say, a color like yellow is a thinner layer of fingernail polish than, say, blue, or purple is a thinner or thicker layer than, say, green. I'm not sure what that correlation is. But when you talk about wavelengths of light, in this case, we're talking about the thickness of this clear material here. This material has the ability to give off or reflect a particular color. As the height of that fingernail polish changes, so does the color. And because this is a solid, the fingernail polish layer is now a solid, it stays in place. It doesn't change. It's always going to be the same. So our variation in thicknesses in here gives us a variation in color. Now, when you're talking about color theory in science, here's the thing. The thickness of your fingernail polish will emit or reflect one color. Okay, that's called the in-phase color. Now, this area yellow here is not going to show green, or it's not going to show purple or any other color. It's only going to show that one color. All the colors that are not shown here in this yellow area are called the out-of-phase colors. We are getting the color that is showing in phase and nothing else. The out-of-phase colors are not visible to our eye. Only the in-phase color in any given thickness area of this fingernail polish is showing that particular in-phase color. Now, I hope you get a chance to try this experiment at home. Watch the safety, please. Be careful, this stuff is combustible. Watch the smell, please. Send me your pictures of your work, and I hope you have fun with this. And ta-ta, take care, see everybody, and have fun with it.